Hello everyone. Today I'm going to teach you the chapter that is geometrical isomerism, which is you have in the pharmaceutical organic chemistry third. Okay, so let's see that. So here I think you can see the screen now, and as you know, this unit is very lengthy. So I have divided into two parts. So let's start with that. Okay. Right now you can now you can see this pharmaceutical organic chemistry third unit 2 geometrical isomerism, right? And I will start with my introduction. Myself Priyanka Chandak, and I'm working as an assistant professor. Okay, so this is my info. You can see here. Now let's start with the flow of presentation. The flow of presentation is, it's, as you know, this is the we have to start with the basics. So flow of presentation, first isomerism, followed by that geometrical isomerism, then nomenclature of geometrical isomerism, then next is method of determining configuration of geometrical isomers, then conformational isomerism in ethane, n-butane, cyclohexane, followed by that stereoisomerism in biophenyl compounds, also known as atropoisomerism, and the last one is stereospecific and stereoselective reaction. So this is you have in the second topic of POC, that is pharmaceutical organic chemistry third. Okay, so we will divide into the two parts. First we will cover the first 4 points, and in the second part we will cover the second 4 points. So here basics of isomerism. So isomerism, so this term, this is very important term, and you know the basic definition of isomers, which you have studied in 12th standard. These compounds possess the same molecular formula but different from each other in physical and chemical properties. It is known as isomers, and this phenomenon is called as isomerism. So it's very simple, like you know, we can say how you can remember this. You can just remember one term same molecular formula, so automatically you will get that is a different structural formula, different physical and chemical properties. It is known as isomers. So mostly in this topic we are going to focus on the most important part, that is geometrical isomers and types of geometrical isomers. So before going to start, you know, isomerism mostly divided into structural and stereoisomerism. Okay, you can take the screenshot as well, so you can, it is very easy to remember in exam, you can write in exam as well. Okay, so here you can see isomerism, it is divided into two, structural and stereoisomerism. Structural, it is divided into 4, functional, positional, chain isomerism, and metamerism. Okay, these 4 you have already studied in 12th standard, and I guess you have studied in 10th standard as well. Then now in stereoisomer there are two types: geometrical isomerism, optical isomerism. So geometrical isomers, I have highlighted this because this is what we are going to focus on today. Then next we'll start with the types of geometrical isomerism. Before going to start the types of geometrical isomerism, I want you to understand these two terms, that is conformation and configuration. Okay, so this image I have put from the Google itself, but this is very important. If you once you understand the difference between conformation and configuration, then it is very easy to understand the remaining all the terms which you have in this chapter. Okay, so you know conformation and configuration, both are the 3D arrangement, but the little difference is there. See, conformational, these are 3D arrangement in the space of the atoms in a molecule, which are interconvertible by rotation around a single bond. Okay, and mostly configuration is, it's not rotatable. Okay, it is not interconvertible by rotation around the bond, because double bond is there and it will restrict the rotation of the bond. Okay, it will restrict the rotation of bond. This is the most important thing. Okay, so you can remember this thing here. And mostly conformation, so you have heard like conformational isomerism in ethane, butane, hexane. and configurational isomerism in butene, ethene, like not ethene, propene, butene. So mostly configurational isomers is the compound which is having double bond, and conformational which is having the single bond, double. Basic difference, okay? Not the final one, but basic difference. Then geometrical isomerism. Now start with the definition. The isomerism which arises due to restricted, that is the frozen rotation about double bond. That's what I said, like this C double bond, C, just consider this X, X, Y, Z, okay, or here A, you can just consider A. So like this, because of this double bond, it will restrict the rotation of the double bond. So that phenomenon is known as geometrical isomerism. Now, this isomerism shown by various compounds such as compounds containing double bond C double bond C, C double bond N, N double bond N, compounds containing cyclic structure and restricted rotation. So these are the three, we can say the requirements, or we can say these are the conditions by which it will fill the criteria of geometrical isomerism. Means you need to remember the compound should have carbon-carbon double bond, or carbon double bond N, or N double bond N. I hope you are getting my points, and if you don't understand anything, or if you are not getting anything, please put in chat box. Now restricted rotation of double bond. Here I am going to show you the image. See, this is double bond, this is the single bond. So now see, now this image will rotate. Here you can see the rotation, right? Only the side of the two molecules, which is either side of those carbon, is rotating, not this complete rotation is occurring, right? It is known as restricted rotation. Then condition for geometrical isomerism, there should be restricted rotation about the bond in the molecule, like we have seen in the previous slide. The restricted rotation should be there. Both substituents on each carbon about which rotation is frozen and restricted should be different, right? This is very important. Here you can see, means if double bond is there, then you have to consider the carbon, the atom which is attached to the first carbon, and the carbon which is atom which is attached to the second carbon. That should be different. Then it shows the geometrical isomerism. Okay. Yeah, that's why here you can see in the box I have written A is not equal to B. Means we cannot consider. We cannot consider A is, means we cannot consider isomerism regarding this, like either side of the carbon, okay, like one side of the carbon. No, we have to consider it like you know, it's opposite side of the double bond, opposite side of the double. Right. Okay, so let's move on to the next. Yeah, so now you understood the restricted rotation. Now you can see here the free rotation. Just see the image. Like, you know, it's rotating. Yeah, it's a free rotation. There is no restriction because there is no double bond. And if double bond is present, 100% restriction is there. But here double bond is not present, so restriction is not there. Okay, the carbon is, that molecules are freely rotating around the carbon. Okay, this is known as free rotation. And mostly this rotation is occur where? In conformational analysis or conformational isomers, you can say. Now, there are three types of nomenclature of geometrical isomer: cis, trans, EZ, and syn-NT. Nomenclature of geometrical isomer: cis, trans, EZ, and syn-NT. First, cis trans, everybody knows what is cis trans, right? So, see, first I will read. This occurs due to the restricted rotation of carbon-carbon bonds, gets two forms, obviously. So, though, if you want to get two forms, means if you मतलब आपको दो forms चाहिए, cis and trans. So what this is the main important thing. Okay, if the same molecules are on the one side of the double bond, it is known as cis. If it is on the opposite side of the double bond, it is known as trans. Okay, So here the isomer in which identical groups are on the same side of the double bond, it is known as cis. The isomer in which the identical groups are on opposite side of the double bond, it is known as trans. So this is very important. Now we'll shift to the next. Yes, examples are very important, and I have just directly taken this example from Behl and Behl books. I have draw and some I have put from the Google images itself. See here, cis to butene and trans to butene. Okay, so here you can observe this methyl group and this methyl groups are on the same side of the double bond. That's why cis. This methyl group and this methyl group. Okay, these are the opposite side of the double bond, or you can say this hydrogen also. So that's why cis and trans. So likewise, this is the second example, this is the third example. So I have given three to four examples. So you can write at least 2 examples in exam. Okay. If they will ask you the nomenclature of cis and trans isomer, then you have to write all those examples. Yeah, so we have talked about the aliphatic chain. Now this is very important. This is like the regarding cyclic chain. How we are going to consider cis and trans in the cyclic chain. So here cis still bin. So this is one phenyl ring. This is second phenyl ring. This is first phenyl ring. This is second phenyl ring. Here you can see the hydrogen atom is from the same side of the double bond. Okay, like double bond, it is on like in one plane of the double bond. Here it is opposite. That's why this is the trans steel beam. Okay, then now next see, please pay attention. So you will get that 100%. So this is question for you. You can solve this question is that which of the following compound had geometrical isomer? So you can identify and let me know. Second question, again you can take the screenshot and write it down and find out which of the following is the geometrical isomer of trans 1,2-dibromopropene. Okay, so find out this. Now the second classification, E and Z nomenclature. E and Z nomenclature, Z is for zusammen, that is in German for together. E is for antigen, German for opposite. So I have, let me erase this so I can move further. If the high priority groups are on the same side, it is known as the Z configuration. If the high priority groups are on the opposite side of the double bond, it is known as the E configuration. This group of highest priority on each carbon atom is identified by using the sequence rule. So you have heard about the CIP rules, right? So with the help of CIP rules, you can differentiate Z and E configuration. So this is the best example ever you can study, and you can write in exam as well. C double bond C, that is bromine, chlorine, fluorine, hydrogen. Okay, C double bond C, bromine, chlorine, hydrogen, fluorine. So here, you know, bulky groups, you have to see the which are the priority groups are there. So here in this diagram, you can see highest priority group bromine, and here also chlorine. So this is the C. Here bromine and chlorine, these are opposite side. This is the E. Now the last one, syn and anti-nomenclature. Okay, so syn and anti-nomenclature, this type of nomenclature shown by those compounds which have at least one C double bond or N double bond N group. So mostly it is related to the N double bond N group. Okay, see, syn means same side, anti means opposite side. But about what? Whether it is from carbon double bond N or N double bond N, that's what we have to study here. So please focus on the laser pen. Syn, if hydrogen on carbon and substitute on nitrogen are on the same side, that is known as syn. Anti, if hydrogen on carbon and substitute on nitrogen are on the opposite side, it is known as anti. And this is the best example ever you can study, because aldoxime, mostly scientists has worked on this example for many times. So here you can see the nitrogen is having lone pair of electron, carbon is having this hydrogen, this nitrogen is having OH. So we need to see the position of hydroxyl group and position of hydrogen on the particular carbon and nitrogen. So here you can see this hydrogen and OH on the same side. That's why it is seen. Here you can see this OH and hydrogen are on the opposite side. That's why it's a anti. This is anti. Okay. And remember, aldoxime is the most important example. Here one more example, that is cycloaldoxime. So you can see that, right? So yeah, thank you very much. You can study this. That is the classification of geometrical isomer. We'll see in the next part, that is the methods of determination. Okay, methods of determination of configuration of geometrical isomer. Thank you very much. If you like my video, then you please put in comment box, so I can make a complete whole video of 1 hour, or I can just bifurcate into the simple parts. Okay, yeah, thank you.